everyone. I'm going to try and do a demonstration of what we've managed to do on the cluster with regards to Jade and the simulations for the agents. What I'm logged into here is the head node for our cluster, and we have a tool on HPC 2008 release 2 which is for setting up and managing jobs in the cluster. What you can see here is we have 6 different nodes, different compute nodes, and we have one head node. That's the computer which I'm logged in to at the moment with remote desktop. And if we click on each of these, you can see that each of the compute nodes has 2 processors. Each of the processors has 4 cores, and therefore we've got 6 times 2 times 4, which equals 48 different cores on the cluster. We can send out to each of these compute nodes programs which we want executed on each of the cores. To be able to do that, there's a job control language. Now here's an example of it here which I've used to execute this program. The simple program that we have is what I sent you before, the cluster agent test and the another agent.java program. The cluster agent test program, what it does is it just creates 1,000 agents, right? So there's a for loop in here which creates 1,000 agents. It sets the agents up to do things. They don't do very much, it's just out of the example code which comes with Jade, and then there's a piece of code down at the bottom which shuts Jade down. This is code which has got to be in here because we are running Jade applications without a graphical user interface, and they run in batch mode. The another agent class and program is just lifted from the Jade example code, and it just very simply just sets up an agent to do very simple behaviors. So what we have here is a program, clusteragent.test, which starts up 1,000 agents, which eventually will be frogs, does something with them, writes some information to a file, and then shuts down. That's all it does. So this program, to be clear, will be one simulation. It does not communicate with any other programs. It just creates 1,000 different agents, all communicating within the one process, each running on a processor core. Now, in the batch program, what we have is what looks quite complicated, but really isn't. What we do is we tell it what nodes we want to run the program on. There's a Windows share directory which allows us to pick up common data. There's a switch which says parametric, and you'll also see there's some wildcard characters, the stars through this. What is happening is that this value 50,000 is given to the first process, 50,001 to the second, etc. up to 50,479. So what we are doing is we are running 10 consecutive batches of 48 separate simulations, all running at the one time. In total 480 of these. Okay, so each of these simulations will take separate input data, will run to completion. We'll do 48 of these at a time in parallel, and then we can move on to the next 48. That's what it demonstrates. There's some stuff in here which sets up some environment variables, class path for Jade, and there's also the actual run of the Jade program, java jade.boot. This minus core is passing in a command line argument which all the agents can pick up. It's just an example of doing this. So this is just a name that I have picked, and it allows this value to be picked up. 50,000 for the first one, 50,001 for the second one, etc. up to 50,479. And I've also put this in here, minus port. This means that every Jade program runs on a separate port. This is necessary because if you cannot run separate instances of Jade on the same computer at the same time with the same port number. So this really has to be worked upon There's probably better ways to do this, but this is what I have done at the moment. So, back to the cluster. If I look at the cluster, I see this, and this shows me the computer nodes which are in the system, in the cluster, but I can also monitor jobs. I've run this previously and I'll run it again now. So if I run that batch program from the command line, what I get now, you can see here, is that it starts executing and it says running there, and it goes up in blocks of 10% because it does 48 at a time, then it does another 48, then it does another 48, up to 480. That's just an arbitrary choice on my part to do it for that length of time. So we'll continue to do that for a few minutes, up to 100%. If we look at the output which comes from these programs, then you can see that this is the folder where all these files were. There's a Jade out and a Jade Air. You can separately send the output from standard output and standard error to separate files. If we look at Jade output, you'll see that you have a file from each simulation run. So if I double click on one of these, you can see you get some information. So it prints out some information for each of the agents in each simulation. It prints out the 10, which comes from the command line argument from the parametric sweep, and this step is 4 is from the actual application. That's kind of irrelevant. And we get the agent name. So ultimately, I would anticipate that these become frogs. Yeah, so if I start up another one, you can see the difference. It says 18 and it's in file 18. Now, presumably, you can also pick up input data for each of the simulations from a file. Well, you can try that. We haven't tried that, but that seems to be easy to do. The other thing you could do, of course, is use the name or the number as a database key. We have not set primary key, we have not set that up either. We're just simply using files. So you can see we have lots of these. We have 480. And if we look back, yeah, we can see that the thing has almost finished. It's sitting there at 99%. Right, okay. Well, I hope that's a bit clearer. In summary, we're running 48 separate simulations at a time, one on each core. They are not communicating, and I have demonstrated that you can execute a sequence of 10 of these 48 simulation executions, one after the other, in blocks of 48. Thanks.